Hi, Assalamualaikum. My name is Ifa Adik Kurnia bin Muhammad Ramzi. I'm from Group 3. Our group consists of 4 people, including me, which is Fadil Arshad bin Muhammad Arif, Farid Aditya Sukada, Hasibu Islam. Today, I would like to present to you about our group introduction. First and foremost, in this project, we are given the task to analyze the bracket deformation of the structure depending on the design force and apply force on the bracket. The property of the project is given in the question. To begin with, we analyze the deformation of geometry of bracket by adjusting the length of the bracket. For the question, we were given each design bottom and upper boundaries. So, the analysis test was carried out by the goal of keeping the design maximum stress below 1800 megapascal. For the project, we decided to use SolidWorks as our AutoCAD software, which is why we is quite familiar with the AutoCAD software, SolidWorks. According to the first analysis, the mesh should be decreased as the length increase. Our objective of the project is to investigate the deformation geometry as a result of axial stress with variance of length. Second, to optimize the design, the bulk should be kept to a minimum and the maximum stress should be less than 8300 megapascal. Our methodology in this project is to use CAD software to modeling the figure, provide a finite element model that includes boundary condition and apply force that was given in the question. Carry out parametric study by changing the length of the bracket. Lastly, to carry out the design optimization with a boundary given in the table to minimize the mess. This is the table that the properties of the lower and upper boundary of the design parameters in millimeter, which include B1, B2, B3, B4, and B5. It has its own lower bound and initial value and upper bound. This is the geometry of our bracket, which is we need to transfer it into SolidWorks and then transfer it to the Finite to analyze it. Finite application to analyze it. Then this is our discussion about loading and boundary condition. By using Finite software, we import the figure that we make in the SolidWorks to measure geometric scale factor used. Given the property above, we will mesh the model to obtain the component and nodes needed to predict the desired result. To begin with, the boundary condition are given in the question with initial bracket design with following value of B1 and the others. Therefore, by using Finite software, a finite element model will be initial value and boundary is plotted. After using Finite, force equal to 15 kilonewton is applied at the center of the upper hole of the bracket. This is the diagram of our first step to complete the analysis. First step is to apply force on the center node of the bracket, and the second step is to apply force on the center node. Third step is to apply force on the center node, and this is the constraint on the surface. Okay, next, I will pass it to my friend to present the other part of the report. Thank you.
Okay. By using Vmap software, we import the model from SolidWorks to ensure the measured geometry scale factor used. The maximum stress plot and the deflection will all be tallied with the required. So, to begin with, we need to analyze the deformation of geometry of the bracket by adjusting a B1 to a different length. The first length is 55 mm, second one is 60 mm, third is 65 mm, fourth is 70 mm, and the last is 75 mm. All these parameters will be applied with the same force at upper hole, this one, with 50,000 Newton. Okay, so this is the result for B1 equals to 55 mm. This is the mesh geometry bracket with boundaries condition. And this is the maximum stress of the design. This is the result that we get with 60 millimeter. This is the mesh bracket geometry with boundary condition. And this is the maximum stress of this design. Okay, and this is the for B1 equals to 65 millimeter. This is the mesh bracket geometry with boundaries condition. And this is the maximum stress of this design. Okay, and this is for 70 millimeter. Okay, this is the mesh bracket geometry, and this one is the maximum stress of this design. And for the last one is 75 millimeter. Okay, so this is the bracket geometry with boundaries condition, and this is the maximum stress of this design.
For the next optimum design analysis, I will continue the presentation. So for this project, we are required to analyze the optimum design by changing the dimension of B1, B2, B3, B4 and the B5. But the final design that we must create must follow the project requirement, which is the maximum stress is 100 megapascal. So here is the table of the outline, which is the design for B1, B2, B3, B4, B5, the lower bound and the upper bound for the dimension. So in this project, we are using 4 trials to see which dimension is optimum for the bracket. So I will start with the first trial, which is B160, B215, B315, B4 and B59. So the maximum stress we get is 223 megapascal and the weight is 0.212 kilogram. So after we using VMAP, we get the stress contour is like this and the deformation geometry of the structure is like this. And we use the second trial, which is we changing the B1 to 65, B2 B3 15 and B4 B5 9 mm. So the next maximum stress we get is 227 megapascal and the weight is 0.20666 kilogram. And also for the stress contour for this structure is like this, and the deformation of the geometry is as we can see. And after seeing the stress is quite low, so we do the third trial dimension, which is B1 110, B2 B3 15 mm, B4 and B5 is 15 mm. So we get the maximum stress applied on the bracket is 435.8744 megapascal and the weight of the structure is 0.19912 kilogram. And the stress contour that we get is like this, and the deformation geometry of the structure is like this. And the final tri-dimension that we try using VMAT is using dimension B1 120, B2 B3 9, B4 and B5 9. So the maximum stress we get is 565.2526 megapascal and the weight is 0.20327. So based on the trial that we has run in the VMAT, we can see that the third and fourth trial is better than the first and the second trial, since the maximum stress is a bit higher, which is 500 megapascal and it not exceeding the limit 800 megapascal. And we can also see the structure is 0.2 kilogram. So this is the stress contour for the fourth trial and the deformation geometry of the structure.
Assalamu alaikum. Good day. This is Hasibul Islam from Group 3. So I'm going to present the discussion. So according to the analysis, the maximum stress at the bracket circumference increase as the upper hole increase. We use Young modulus 206.8 gigapascal, Poisson ratio 0.29 and the density 7820 and the thickness is 3 millimeter. 15 kilonewton force we use for all the parameters. For 50 mm, the highest stress we got 181.159 megapascal, and 75 millimeter for the maximum stress is 192.660 megapascal. By using the safety factor formula for 55 millimeter diameter, we found 4.42, which is safe. If the diameter increase, the deflection will be greater. From analysis, we see the mass could be reduced if we maintain maximum stress of less than 800 megapascal. Max stress value of the optimized brackets 181.59 megapascal. So we decide by improving bracket safety factor is 4.42.